also from my side. Can you see my slides?
Yes.
Okay, great.
Yes.
Thank you. So good morning, everyone, and welcome to our webinar. Thank you for joining and showing interest in our project. So before delving into the details of the webinar on how to experiment with our platform, let me briefly say a few things about our project. So 5G-IANA is a Horizon 2020 project. It will last for 1 more year, so until November 2024. The consortium consists of 16 partners, among which 10 are SMEs. And actually, our project gives a lot of focus on SMEs, both from inside the consortium and outside of the consortium. The project has 4 main objectives. The first one is to provide an automotive open experimental platform that is given at the disposal of third parties. And by third parties, we mean any external entity, SME or startup that is interested and willing to do some kind of experimentation by using our open platform. The second objective is to implement an open repository environment for network applications and virtual network functions, through which it becomes really easy and intuitive to create and design new automotive-related services for SMEs. Then one more objective is to trial some automated and connected driving use cases that come from the consortium, through which we can validate exactly this open experimental platform that I mentioned before. And then by offering all these previous 3 objectives, we expect to create new business opportunities for startups and SMEs working in the automotive sector or generally mobility-related sector. The use cases that the consortium is developing and offering are 7. So there are cases on remote driving, maneuvers coordination for autonomous driving, virtual bus tour, augmented reality content delivery for vehicular scenarios, high-risk driving hotspot detection, network status monitoring, and situational awareness in cross-border scenarios. So these 7 use cases are in the final stage of being validated in one of our test beds, while development continues for a second cycle of development and validation. And now, regarding these third parties that we invite to use our open platform, we expect some gains to offer to them. So the first one and most important is that they gain access to this canvas of technologies where they can develop new functions and services in the automotive 5G landscape. Then they can test and validate their existing or new services or products or scenarios in real time using 5G connectivity. This means that they can either experiment with a new service or even a new hardware product, and they want to see how it behaves in a real 5G environment, or they just want to trial a specific scenario, a use case, and see how, again, it behaves in such an environment. Also, the third parties can gain access to real-life 5G resources that the project possesses and offers. So these are vehicles, onboard units, roadside units, and edge and MEC servers located at our 2 test beds. And also, in parallel, they get continuous mentorship and support from our side. We give them the opportunity to explore new business models and actually sit together and build some business models that help them locate themselves in this 5G era. And finally, they gain visibility for the Commission through our social media channels, our website, our reports, etc. The 2 test beds of the project are the following. The first one is located in the city of Ulm in Germany, which is operated by Nokia, and the second one is available in Ljubljana in Slovenia, operated by Telekom Slovenia, and both are 5G standalone test beds. Now, this is my final slide, just to give you some hints about the open call that we're going to announce. First of all, let me mention that the first open call of the project is close to be finalized, and this means that some third parties, so some SMEs and startups, have already exploited our hardware and software, and they have concluded their experiments. We are now in the phase of reporting mainly. But the second open call of the project is expected to start in a few weeks from now, to open in a few weeks from now, so in December. We will have an info day somewhere probably after the new year where we will explain all the details about the open call. And the deadline will be open until March. And then in April, we will announce who are the eligible experimenters. And by eligible, we mean experimenters that propose some scenarios, some tests that can be, first of all, it's feasible to be done in our platform and test beds, and also they have some interest for our project. Then in April and May, we will do the pre-testing. So this is the phase of helping the SMEs get familiarized with our platform, with the offerings that we have. And actually, we help them create a feasible and interesting for both sides experiment. Then in June and until September, we will have the actual experimentation and validation process. The SMEs, for example, can even travel to the test beds if needed or if they prefer to do so, and collect their results in real time. And then in October, so almost in 1 year from now, we will have the reporting of the SMEs, and we will also give some awards. We are currently in the stage of finalizing the open call details, but we are considering to give some money before, so together with the announcement of the eligible experimenters, so that we facilitate them in devoting some resources for this kind of experiments. And then after the end, the successful end of their experiment, to get the other half, for example, part of the award. This is all from my side. Thank you very much for your attention. And Dimitris, do you want to take some questions now, or first
Yes,
we have the...
Yes, thank you, Rini, very much. Yes, if there are any questions, we can take them now or either at the end of the webinar. Do you have any questions for Rini? You can raise your hand. No, as I can see. So let's proceed to the main part of the event, of this webinar. We have the pleasure to have together Matteo and Dolphy. Matteo works at Networks, and he will do the presentation about the nApp onboarding and the 5G-IANA platform capabilities. Matteo, the floor is yours. You can start.
Yes. I don't know if you can see my screen.
Yes, absolutely. You can start. Thank you.
Good. So, hi everyone, and I'm Matteo Andolfi, a project manager from Networks, a partner in the 5G-IANA project. And today I want to show the procedure to onboard a nApp and to use this nApp in a 5G testbed environment. So, first of all, I want to introduce a little bit the agenda of this webinar. So we can, in the next slides, we talk about the 5G-IANA AOAP, Automotive Open Experimental Platform, and then we deep down, we focus on the deployment, on the development and the deployment of a whole nApp composed by some component. And so we start to let's say, design this nApp with all the components, and then we proceed with the onboarding of the nApp and then deployment of the nApp. So at the beginning, I want to introduce some glossary that I will follow in the presentation. So an atomic component is a virtualizable function deployable in a container. So every component introduces some logic or introduce something inside our nApp. And of course, a nApp is a composition of these atomic components linked together, and that can be deployed on a 5G infrastructure and then can use 5G services. So why we can use the 5G-IANA OAP? The 5G-IANA OAP provides a unique entry point for using and automatically orchestrating the 5G resources that reside in a testbed. In this case, in the following presentation, we will use the Nokia testbed in Ulm. The main advantage of using the IOAP is the easy of use for all the user. So the user doesn't need a strong technical background to use this IOAP. In addition, the OP provides a single entry point, as I already said, where user can access, use the components made available by providers, or the providers, or the third party itself, create new one, and combine these components to build their own application that use the 5G resources in the testbed. So the use of 5G resources has never been so simple. Thanks to the IVP, the third party can develop their own application and leverage the 5G resources provided by the testbed to test their experiments in the automotive sector in this case. So this is the list of the nApp that will be provided by the 5G-IANA project. So as you can see, some of these network applications and some of these components are grouped by, are categorized in some, let's say, in some categories that include the industry 4.0, the automotive sector, of course, the smart city and utilities, and so on. So third party can use this component, this nApp, in order to create some other nApp that exploit the feature, those feature, and create new application to provide the new benefits to the user. So let's deep dive into the development of an atomic component. As you remember, the definition of the atomic component is a piece of software that is containerized in an image. So the development life cycle is like the development life cycle of a software application, but there are some difference. The difference between a network application, an app, and a normal application refers to the 5G network and the connection requirement. For example, a remote drive application can exploit the 5G network with processes that are running on an OBU and processes that are running on a Mac server. In addition, a network application or an atomic component can be described with a blueprint that is a descriptor in JSON format that contains all the relevant information of the component. For example, the image used, the recorded network slice, the list of interface, and so on. We can see the blueprint JSON, an example of a blueprint JSON in the following slide. So, starting the development life cycle, we have the first three steps that are the requirement analysis, the design, and the implementation and testing that can be done by a developer in order to create a brand new component inside the 5G-IANA testbed. But otherwise, we can skip this step if a third party want to use a already developed component. In this case, after we define the requirement of our component and after we design our component, we start the implementation of the component, and if the component is open source, we commit it in the 5G-IANA repository. The 5G-IANA repository is a GitLab that is hosted by a partner of us that is Ubitech, and in this GitLab we have a project, we have a group called 5G-IANA that is organized, as you can see, in platform, use cases, component, and so on. In every project that we can host, we can store in this GitLab. Every project is organized in this way. So we have the code, the open source code, And then we have a README that explain to the other user or to third party how what the component does and how we can use this component. After we commit the code of a component inside our GitLab repository, we can start to upload the component inside our 5G-IANA NetApp toolkit. For this, we have developed and deployed some CI/CD pipeline that is shown in this picture that automatically compile and build and push the images inside our centralized registry, our repository. So as you can see in this picture, you can see that a component is automatically built and pushed inside our centralized registry. But what is the centralized registry? The centralized registry is a repository that contains all the images that are used in the 5G-IANA. Those images can be, of course, can be open source, can be open use, or can be private. Of course, the private images doesn't rely on the GitLab repository, but relies, of course, on a developer environment, and then are pushed in a private manner inside the centralized registry in order to be used only by that developer, that third party. So let's say the big feature of the centralized registry is that it's private. So something can be stored privately in the centralized registry without the use for another partner. After that, after we build the images and we push on the centralized registry, we have the onboarding procedure. So we onboard the component and the NetApp. We create the NetApp and we onboard it on the 5G-IANA environment. So as you can see here, we upload the component inside our composer with a very easy to use GUI that contains that needs to be filled by via some information. For example, where is stored the images on the centralized registry, where are the environment variables that are provided by the component, and what are the exposed interface that the component exposes to the outside. And after that, we can see those components inside our canvas. Those components are uploaded on the composer and can be viewed in the canvas and can be linked together in order to let's say let them communicate. After that, when you click on save, so when you save this NetApp, because this is a NetApp, because it's a composition of atomic component. When you save this NetApp, there is an automatic process that onboards this NetApp on our catalog. So the NetApp is onboarded, and there are some information in JSON format that are stored in the blueprint that I mentioned before. In this case, you can see in this picture that there is a blueprint, and for this example, I use the network monitoring NetApp that is composed by two components. nTop-ng, that is a network monitoring tool provided by third party. So we don't have the open. It's not open source, but it's open to use. So we get this information, this component by via nTop-ng stable, and then we have another component that is a network monitoring driver that is open source, developed by us, and is linked here in the centralized registry. When we onboard the nApp, network application, inside our catalog in this automatic way, we obtain the deployable nApp. In this case, we have the nApp that is depicted in the figure, and we have to provide to this nApp some information regarding where to deploy and how to deploy this nApp on the 5G testbed that is linked on the composer. So, for example, you can see here that I want to deploy the component netmon 441 that is on the nApp on the 5G-IANA Mac server. So in the 5G-IANA testbed environment, especially in the Mac server, or from this drop-down menu, I can choose also the OBU and so on. And after that, we have we move to the deployment step, and in this deployment step, we let's say we get the slice to use to deploy the network application via the application orchestrator called the VAU, that is an Ubitech component, and this application orchestrator get the nApp, get the slice to be used, and deploy the network application inside our testbed as Kubernetes pods. Because in our testbed there are a Kubernetes cluster used. We use the Kubernetes cluster, and we organize the deployment like a Kubernetes deployment. After we finish the deployment phase, we can see here that we have the nApp, the network application, up and running. For example, in the background of this slide, we have the network monitoring component, and in the foreground of these slides, we have the network monitoring driver component that get the information sniffed by the other component. Now I want to show you some hands-on on the real testbed in order to explain me a little bit better. So I want to get the here we have, as I mentioned before, we have the component. The component I've committed this component, this open source component, inside the GitLab platform. Here you can see the README, so the documentation of the component, how you can use the component, and then in the pipelines you can use that. You can see that we have some pipeline that are passed, that are every pipeline compile the code and build the images and push the image on the centralized registry. You can see here pushing image to 192, that is our registry, and we can go here inside our registry, and we can list the images that are inside the decentralized registry, and here we can see the network monitoring. After that, we can go when all the information are stored and are uploaded, when all the images are uploaded on the centralized registry, we can go, wait, I have to get the, we can go on the composer. I want to show you the composer because it's a very simple tool to use. And here we can create some, we can upload the images that we used. For example, then as I showed you before, the net monitoring driver, the network monitoring driver, that is the network monitor that I showed you previously, and that has, for example, some exposed interfaces, so some interfaces that are exposed to the outside, some labels. I can categorize the component with some labels, and I can use some environment variables in order to create some complex components. After that, I can create a network application. I want to create this network application right now. Net monitoring, and I can add some components directly from this menu. So, for example, I want to add the net monitoring, and where is the other? If I can search it, and the net monitoring driver. As you can see, the network monitoring driver uses the net monitoring, so I can get this. I can draw a line from the network monitoring driver to the network monitoring in order to say, okay, the network monitoring driver uses the data from the network monitoring. Then I save. And I can, from now on, I can use this application in order to deploy it on a testbed. So I use a name. I need to put a name here. And then I can choose, for example, okay, I want to select a node in order to deploy these components. I will show the Mac. I will use the Mac server, and then of course also in this case I will use the Mac server and so on. And here I can choose, of course, the slice of the 5G that I want to use. For example, the MBB or the URLLC. And so on. I don't go any further because now in this case we have a problem in our Kubernetes cluster. But when you finish, you need to click on proceed, and the nApp is deployed on the cluster. Returning to the slide. The only thing I want to conclude saying that the AOAP is very easy to use, and is a platform that can be used for linking components, developed also by other partners, and so there is this interconnection between the partners that can be used the other components in order to create very new application to be used in the real world, in the automotive, of course, scenario. And then we have a very direct connection to the 5G environment in this AOAP in order to experiment this application. And this is all. If you have any question, please feel free to ask me.
Thank you, Matteo, for your presentation. And now we open the floor for any questions. So you can either raise your hand, open the camera, send it at the chat, whatever you you want. So, any questions for Matteo? No.
Yes, I have one.
Yes.
Hi, I'm Achille Montanaro. I thank you for your presentation. Just a quick information about the initial slide. It was shown that it's possible to provide real-time performance with this environment. What real-time means? What kind of control you have on the time execution? If it's possible to guarantee any real-time services with a given maximum delay of execution.
Yes, let's say I want to show again the slide. Do you mean this slide?
Yeah, in this slide, if it is possible to guarantee there is any way to control, to limit or to have a real-time performance, what kind of, or what real-time means?
Yes, of course, we can let's say limit the real-time performance, or we can let's say analyze the performance in real time, because we have the monitoring analytics component that I didn't mention it because it is not in the scope of this presentation, but there is a component that monitors the network application inside it, and decide, and also the DML orchestration, and decide when the performance of the network application needs to be, let's say, reconfigured, and we can maybe redeploy the network application in order. I want to say it better. We can migrate the network application maybe in better slice that can be provided by the 5G network.
Thank you.
You're welcome.
We also have a question on the chat from Mr. Angel Martin Navas. Do you have any documentation online already?
Yes, we have some documentation online, and it is on the 5G-IANA GitLab platform. I don't know. I'm asking Guerini if we can provide this documentation to third party, but I think there is no problem to provide it.
Yes, that's true, but also there is even information that is even easier for third parties to understand. So we have prepared a technical manual, as well as a library documentation of all our network applications and provided virtual network functions. What will also be very valuable will be the next info day, where we will try to explain to you what are the capabilities that you can gain through our platform, because now the presentation of Matteo has been, let's say, the most complex scenario, where you log in the platform, where you do everything on your own. But this will not be the case. You will have our support. So the case might be that you provide just one circle, one atomic component. This might be the software that you want to test, and then we can help you chain it with the rest of the network applications, help you deploy it on our test beds, and so on. And also, of course, we have the public deliverables, but maybe some of them are more complicated. But okay.
Yes, of course. So you can ask us your objective, and then we can support you in order to provide you some components or some nApp in order to let your objective to come true, and so on.
And of course, this webinar and the other webinars are all. This webinar will be at our website, and you can find the link in the chat for the previous webinars. And we have another question again in the chat. Are the nApp developed inside the project consortium timeframe planned to be released as some specific license option?
Wait, I have to read the question. Yes, we can let's say every component can have can have its specific policy license. So I didn't see that the question. Sorry for that. Okay, it's in the shot. Wait, I have to read read better the question. Other than that, inside the project concept transfer time to be released as some. Yes, the network application will be developed by the consortium. Will be developed by the consortium and give and let's say and given to the third party with some license option. Of course, some network application will be open source. Some other network application will be open use and so on. Maybe a few of the network application provided by the consortium will be private, but I think there will be very few. So the one listed here in this slide are all open use, and some of them are open source, of course.
Thank you, Matteo. Do you have another question for Matteo or for Irini? No, as I can see. I don't know, Irini, if you want to add anything before closing the webinar.
Yes, I would like to add that if we have people in the webinar from SMEs or startup that find interest in our project and are thinking about applying to our open call that will open in 1 month or so, perhaps they can get in contact with us beforehand so that they can ask for more details, and we also add their emails in our list so that we make sure that they receive the notification about the open call. So I can share now the email in the chat.
Perfect. And of course, you can follow 5G-IANA on our social media. I will also share the links in the chat, and we will be more than happy to be in contact, either in the framework of the call or in general. So I think we can close the webinar here. Matteo, do you want to add anything before ending the webinar?
No, if I haven't to add anything, thanks.
So thank you very much. Thank you all for being here, and see you at our next webinar. Bye-bye.
Bye-bye.
Thank you.
Thank you.
Goodbye.
Bye bye. Thank you.